Hey, Science 10s, this is Mr. Walton here. Today we're going to go over mechanical energy. And the idea behind mechanical energy is that it's the total amount of energy when you add up both the kinetic and the potential energies of an object. So what we're really saying is we're saying that it's the energy due to the motion and the position of an object, or like the elevation, how high it is above the ground. So the best way to really kind of explain it is just to talk about a situation. So here's a little bit of context. Imagine an archer shooting an arrow into the air. Let's take a look at what happens to the potential and the kinetic energies as the arrow travels through the air. So let's say we got an arrow and it's being launched up, and it's going to go up, and then it's going to come back down. And let's take a look at it at a few different points in its path. Let's take a look at it at point A, at point B, and then at point C. So at point A, you can think of this as the moment that the archer lets this arrow go. It's got the least amount of elevation, like it's the closest to the ground, right? So there's very, very, very little potential energy, but it's also moving the fastest. Think about if you were to throw something in the air, it's moving really, really quickly. It's moving super quickly up at the beginning, and then it starts to slow down as it travels through the air. And so in situation A, we've got lots of kinetic energy, but we've got very little potential energy. In situation B, or kind of halfway through its journey up into the air, it's slowed down a little bit. Remember, gravity is always constantly pulling down on this arrow. And so the arrow's slowed down a little bit, right? And it's kind of halfway up through its journey up into the air. And so it's got a little bit of kinetic energy, and it's got a little bit of potential energy. And then finally, we think about situation C, which is right at the very top. If you were to throw something in the air, if you were to shoot an arrow straight up into the air, it's at the apex of its trajectory, at the very top of its flight. It's just for a tiny fraction of a second, it's not moving at all. And so it's got very little kinetic energy, but it's also at the top of its flight path, right? It's at the highest elevation that it'll get. So it's got lots of potential energy. And the thing you want to think about here is that in all three of these situations, we all have the same mechanical energy. So all three of these situations have the exact same mechanical energy. If you were to add up the kinetic energy and the potential energy, let's say it would add up to 100 joules here. Then in situation B, if you were to add up the kinetic energy and the potential energy here, it would add up to be 100 joules again. And then in situation C, it would add up to be 100 joules again, just by way of an example. So you can think of it, what's happening to the kinetic energy? Let's take a look at it. What's happening to how fast this arrow is moving through its trajectory? It's going super fast at the beginning, and then it's stopped at the top. So it's slowing down. Its kinetic energy is decreasing the entire time. It's just slowing down the entire time. Now, what's happening to its potential energy, right? It's really low in elevation up here, and it's really high in elevation up here. And so its potential energy is gaining and gaining and gaining. So we got low potential energy here, and it's going up and up and up and up and up. Basically, just the kinetic energy is being transferred into potential energy the entire time. And then as it goes down, as this arrow goes back down, then the arrow starts going faster and faster and faster, and it starts going lower and lower and lower. So then when it goes down, the potential energy is being transferred back into kinetic energy. But the total amount of energy of the arrow, right, should be the same the entire time. That's why this idea of mechanical energy is actually really important. It allows us to kind of keep track of the total amount of energy that's being transferred between kinetic and potential energy. So we're going to go through an equation here. It's fairly simple, but it's not in your data booklet. You have to either memorize this or you have to look it up in your notes every single time. So mechanical energy, we just say EM for mechanical energy is equal to the sum of the kinetic energy and the potential energy of an object. So remember, this really means mechanical energy. And then EK obviously is kinetic and EP is potential energy. Now we could go a little bit further. Remember, there's an entire other formula for EK, right? EK is really 1/2 mv squared, or the way we like to write it, mv squared over 2. They're the exact same thing, right? And EP is just mgh. They're the exact same thing. So that's another way that you could write this formula, is mv squared over 2 plus mgh if you wanted to. So we're going to do a couple examples here. We're going to do 3 examples. One's going to be easy, one's going to be kind of a medium difficulty, and then one's going to be a little bit harder. And then I'm going to get you to do some questions after that. So question number 1. Mechanical energy number 1. A book is thrown out of a 3rd floor window of a building. If the book has a total mechanical energy of 850 joules and the book has 320 joules of kinetic energy, what is, when it's thrown, how much potential energy does the book have? Squiggly line, as always, right? So let's see. If the book has a total mechanical energy, EM, of 850 joules, and the book has 320 joules of kinetic energy, 320 joules of kinetic energy, how much potential energy? EP equals question mark. Perfect. So if we take a look at the formula that we've been given, we're asking to find the potential energy. Well, how do I get the potential energy? I got to subtract EK from both sides. So really, my new formula is going to be EP equals EM minus EK. Now, you're never going to get a negative energy when you do this. So if you get a negative energy, then you rearrange these improperly. You just messed it up. That's okay. But just go back and take a look at the video. Go back and take a look at your notes, and just make sure that you're doing everything okay. So our mechanical energy, 850 joules, minus kinetic energy, 320 joules. So when we do this, 850 minus 320 is 530 joules. So the book should have 530 joules of potential energy when it's thrown out the window. Okay, perfect, no problem. So that was kind of an easy difficulty. Hopefully you kind of agree with me that wasn't too bad. All you had to do was rearrange this little minor equation, and then, you're okay. This next one is a little bit difficult. You got to do an extra step that's involved, and so, okay, that's totally fine. We'll go through this. A 0.3 kilogram baseball is thrown in a straight line through the air. At a height of 2.5 meters above the surface of the earth, it has a speed of 20 meters per second. What is the total mechanical energy? So, squiggly line, it's got a mass of 0.3000 kilograms. Just, a good review for us. This number has 4 significant digits. Okay, the first 0 doesn't count. Any numbers, out in front don't count until you get to any number, between 1 and 9. So the 3 is good. And then any number after that is going to be good. So the 0, the 0, and the 0, those are good. That's 4 significant digits. Okay, anyways. So a 0.3 kilogram baseball at a height of 2.50 meters, speed of 20 meters per second. What is the total mechanical energy? EM equals ? Well, let's think about this. I want mechanical energy. What things do I need for mechanical energy? I need potential energy plus kinetic energy. Those are the two things that make up mechanical energy. Are you given? Let's go back through the question. Let's go back through here and let's see. Are you given potential or kinetic energy? No. You're not given either potential or kinetic energy. So what we have to do is we have to calculate the potential energy and calculate the kinetic energy, and then we have to add them together. We can do this in two different ways. We can do it all in one big step, okay, by saying that the mechanical energy is equal to the kinetic plus the potential, and we can just write it out, mv squared over 2 plus mgh, right? And then we can substitute in, we can solve it, or we could do this in steps. We could find the kinetic energy, we could find the potential energy, and then we just add them together. And that's what I'm going to do. I'm going to do this in separate steps. And that's totally fine if you want to do this. So step 1, we're going to look for kinetic energy is mv squared over 2. So the mass is 0.3000 kilograms. The velocity is 20 meters per second, so 20.0 meters per second squared divided by 2. So when I do this calculation, we're going to get 60.0 joules. Perfect. And then, so number 2, we're going to find the potential energy. So that's mgh. So the mass, 0.3000 kilograms times 9.81 meters per second squared, because 9.81 meters per second squared is acceleration due to gravity, right? That's the rate of acceleration that things fall at. And then the height was 2.50 meters. And when I do that calculation, we get 7.36 joules. And then finally, we're just going to add these all together, right? EK plus EP. Again, we could have done this in one giant calculation. We could have just done mv squared plus mgh and just done it on our calculator. But we're going to go 60.0 joules plus 7.36 joules. And when I add this all together, we're going to get 67.36 joules, which is actually going to turn into, once we round it, because when we add two numbers together, we got to take the lowest number of decimal places. Don't worry about significant digits. If significant digits are messing you up right now, just don't worry about them. Okay? We can deal with that, in Physics 20 or in Chem 20 or something like that. Just chill. It's okay. Get the fundamentals of rearranging equations. That's the most important thing. So the 6 is going to round the 3 up to a 4, so we're going to get 67.4 joules. Now, I say that was a medium difficulty question because all we did was do, a standard EK calculation, a standard EP calculation, and smushed them together. We just added it up, okay? So that's like a medium difficulty question. Here we have a hard difficulty question. Now, just stick with me on this one, okay? This one's going to be obviously a little bit more difficult, but it's relatively straightforward, okay? How fast is a 2.04 kilogram hawk flying if it has 546 joules of mechanical energy and it is 17.4 meters above the ground? Okay, let's start summarizing. How fast 2.04 kilograms if it has a mechanical energy of 546 joules and 17.4, so that's the height, meters above the ground. And we want velocity. No, sorry. Geez, did I say velocity? Oh my goodness. And we want velocity. Question mark. Good. Okay, let's think about this. It says mechanical energy. And remember, mechanical energy is the kinetic plus the potential. This is all about speed and position, right? Or height or something like that, okay? Now, the 17.4 meters, that deals with the potential energy, but the speed deals with the kinetic energy. So let's just think about this. If you want the speed, what do you have to find first? The kinetic energy. So that's what you have to do. Your first thing that you have to do is find the kinetic energy. Now, how do I get kinetic energy? Well, if you want kinetic energy, you need mechanical energy, which we have, right? It gives us mechanical energy. But do we have potential energy? Look at the question. Does it give us potential energy? No. But we can find it, okay? So we got to find potential energy first, then get kinetic, and then rearrange, okay? I could rearrange all of this just in one big massive equation, or we could do this in steps, okay? So, step number 1, find EP. So the potential energy is mgh, and m is 2.04 kilograms. G is acceleration due to gravity, 9.81 meters per second squared. And the height above the ground, 17.4 meters. And when we do that on a calculator, we get 384.216 joules. Perfect. All right. Step number 2. Now that we have EP, then we can get EK. So EK is just the mechanical energy minus the potential energy. It's the difference between the two, right? So if it's 546 joules minus 384.216 joules, so we're going to get 161.784 joules. No problem. Perfect. And question number 3, the part number 3, the very last part. Now that we have the kinetic energy, now we can get speed. So if we want speed, we got to rearrange the kinetic energy formula. EK equals mv squared over 2. Well, if we want v, the 2 has to go up here, the m goes down here, and then we got a square root. So this is going to turn into v equals the square root of 2ek over m. Okay, no problem. 2 times 161.784 joules divided by the mass, which is 2.04 kilograms. And when we do that on our calculator, we should get 12.6 meters per second as a velocity or a speed. Okay, so that was kind of the most difficult question that I could ask you. And the reason why it's so difficult is because of this thought process up here. That thought process up there is the most difficult thing, is associating speed with kinetic energy and the position or the height with potential energy. Now, as long as you're given the mechanical energy and either speed or position, you should be able to solve for the other one, okay? But again, that's a more difficult question. Let me know if you have any questions. Let me know if there's any way that I can help you out. There's some questions down here that I would like you to attempt. I think there's only 3 questions. Yeah, there's only 3 questions there. So take a look at them. There's additional practice in the textbook. If any of you even have your textbooks at home, I don't really know. So there is additional practice if you want it in the textbook though. So take a look at the filled in notes for the answers for these questions. Email me or come see me in the office hours or something like that. Let me know. I'm here to help, and I believe in you, Raiders. You got this.